Hey guys, it's Josh K here, and I'm guessing most of you, or all of you, have had a uh, November mock test in the great subject of mathematics, and I've memorized 3 questions from that paper, which I would like to go through with you guys. So, yeah, you guys will probably remember that there's one about a circle and a sort of a right angle triangle that went through it. I'll be working on that one. There's a capsule with a hemisphere and a cylinder. That's the second one I'll go through, and the final question is going to be that hexagon at the end, which there's more than one way to do it. You could do it via trigonometry, or you could do it via Pythagoras. So yeah, let's get it cracking, guys. Yeah, I'm gonna be typing important stuff in over here. It's my typing desktop. This is my drawing desktop, I guess. Let's open the stuff. Let's start off with the first one, guys. This is the first one. Oh, yeah. I'll reduce the zoom. 50% would be good, guys. I think, yeah, that's a good zoom for that. And we can keep that there. Okay, so this question asks us to find the angle that goes from here to there to there. Okay? From here to there to there. And we have this angle. But we also know that this must be a right angle, because it is tangent to the circle. So, let's get our toolbox out. God, I hate these things. Yeah, so let's get to work. Cancel. I don't want to be selected on that one. I want now to go to this. I'm going to label this right angle, guys. So that's a right angle. And what we also know is now OB and OA are both tangent to the circle. So we can symbol that as that and that. And we know, since they're tangent, since you know that it's an isosceles triangle, you guys can see, because they're both radii. They're both radii, so it's an isosceles triangle, which we'll come to use later. But first of all, do you guys see the big right angle triangle? OAP. You have a 26 over there, a 90 over here, and then we can work out what AOP is. So OAP is equal to, it's going to be equal to 180 minus 90 minus 26, which we can cancel down to 90 minus 26, which is equal to 64. And guys, if you don't know how I did that without using a calculator, just do 9 minus 2, 7. You know this bit's more than that, so it's going to be actually 9 minus 3, so it's going to be 6. Then that will give us 4, 64. That is what OAB is. That's 64. But we want to then find out what... Now you see that if this is an isosceles triangle, this angle that is over here and this angle over here must be equal. So we can call that x. So you know that 64 plus x is going to have to give us 180. Rules of triangles. So we know we can do that 64 plus 2x is going to equal 180. Now, what can we do about that 180? We can cancel it down, I think, so it would give us 116 is equal to 2x, which should give us 58, was it? I think it was 58 is equal to x. I'll just run that through my calculator, guys. 180 minus 64. 116 divided by 2, 58, yep. And so that means this angle must be 58. This angle there. But then what angle must this be? Well, you guys can see that this angle plus this angle forms a right angle. So therefore, this angle plus this angle must equal 90. So we know 58, so it's going to be 90 minus 58 will give us that angle, which should give us 22, isn't it? If I'm not mistaken, guys, just check that. How can it be 22? 32, silly me. Very silly of me. That has to be 32, because 32 plus 58. Yep. 90, and I'll just check. Yeah, 90 minus 64. Yep, that should be right. Okay, and then you can obviously see that this forms a triangle, sort of a very awkward triangle. ABP, that's the thing we need to find. As you can see, it would obviously be 180 minus 32 minus 26. Is that 26? Isn't that right? So that is there should be something about it. So 180 minus 32 minus 26. Yeah, that should give us 122, which is the answer I wrote down in my exam paper. 122, guys. That is the answer to that question. Okay, so yeah, just to recap, you find out you had to find out that this angle was 68, worked out that this angle was x, and realized that this angle and this angle had to be it had to be 116 equals 2x, which was 58, right? Yeah. You have to realize that both of these angles 58. And by the way, guys, I took a really awkward method around this because I used this angle, worked out this angle, and then I used this. I just realized you could have just done 180 minus 58 to start off with, which would have got you, so 180 minus 58 is equal to 122, which is how most of you got this, but I took it the long way. Okay, guys, so that is that question sorted. Yeah, now let's move on. Let's clear this. I haven't really used this space, have I? I might use this space next round. Okay. File open, recent. Let's do the second question, guys. The second question. Oh, big. 50 again. Zoom out. Okay. So this is our question. We know this. So it's composed of two parts. A cylinder and a hemisphere. And we're going to find the surface area. So what would be, now this, you can obviously see there's three faces. This face over here with the circle, the curved face of the cylinder, and the half face, the half curved face of the hemisphere. So let's use this space for once. So let's do this. It would be the circular face, the curved face, and another face which cannot be drawn in 2D, so I'm just gonna do that. Let's get our equations right. So that face must be pi r squared. Where's my squared sign? Yeah, pi r squared. Guys, that's pi r squared. This face must be it is 2 pi r, because that is the radius of the circle, times by the length of the cylinder. So that's going to be 2 pi r and then L for length. 2 pi r L. And this one, it's not a circle, guys. That's the only thing I had to draw it with. You know what I'm gonna do? I'm gonna draw sort of cross section. Show it's a sphere. I'll make it thicker a bit as I get in. So this is not a circle, it's a sphere. And now you guys know that the surface area of a sphere is 4 pi r squared. But this is half a sphere. So it's going to be 2 pi r squared. 2 pi r squared. So the sum of all these three. And guys, as you can see, you have 2 pi r squared. Pi r squared. That's 3 pi r squared. 3 pi r squared plus 2 pi r L. Let's factorize it. So you can, pi r is a common factor. So it's going to be pi r, and then it's going to be 3r plus 2l, which will then give us pi r. And what's 3r, guys? Well, type this in your calculators. 3 times 3.4 will give you 10.2. I remember typing this in the exam. 10.2, and then you add on the length of the cylinder. 10.2 plus 2 times 8.3, which would give you 10.6. That should be correct. No, why would it be 10.6? 16.6, guys, because 8 times 2 is 16. 3 times, yeah, exactly. Yeah, so, and then you'd get 26.8. I remember typing 26.8. 26.8 pi r, and then just multiply that by something. Wait, just check stuff. I'll just check my work. 3 times 3.4. Yep. 2 times 8.3. Yep. Plus 10.2. Yep. Times by 3.4, guys. So you get 91.12 pi. 91.12 pi. And that cancels down to give you your final answer. 91.12 pi. 200. I won't give you the final answer. It's going to be 286.2619 and some other digits. You need it to 3 significant places. There you go, guys. That is your second answer. So our first answer was, yeah. I'm just gonna close this. Close that. Delete all that. And just write down our answers, guys. For the record. So the first answer was 112. Well, I need to get this font size up, guys. Get it big. 36. That should do it. 112. Just get the degrees in. There we go. 112 degrees. The second answer was, let's do that in 286 square centimeters. So square centimeters, 286 square centimeters. Now we're gonna do the third question, the harder one of all of them. Yeah. File open research and question 3. Good. Ooh, looks. You guys remembered this one. Yeah, it's meant to be regular hexagon. No, it doesn't look regular, but just ignore that, guys. Yeah. It's portrait, not ideal, but okay. Maybe we can live with this. Yeah, so what you see, guys, we have this shape, which doesn't look much like a hexagon. I'll just redraw it for you guys. My redrawing might be worse. I do not know. So it's about that. Oh, it's too thin for me. I need a thicker line. Guys, just give me a second. Okay, 4. Yeah, let's do this. There's our hexagon line. It's about not right, but anyway. Okay. There we go. It's about the same. But, okay, guys. We need to find the area. Now, the perimeter is 42. And then we've got to remember each side is equal. So it's basically 6 sides. 6x is equal to 42. Each length is 7. You can see that immediately. Okay. Now, this is the tricky bit. Now, there's 2 ways to solve this problem. I'm going to show you both ways. Now, I want you guys just to think about it and connect the lines together. Just connect those lines, those opposite lines, and you will see some stuff happen. Yeah, wasn't the best drawing. These are equilateral triangles, guys. Equilateral triangles, because you know that just to prove it's equilateral triangles, you guys, you know that 180 n minus 2. You know that if it's 6, it's going to be 4. 4 times 180, 720. 720 divided by 6. 720 divided by 6 should be 120. Yeah, 120, guys. So that means this each angle must be 120, and because it's bisected into half, it's 60 degrees. So all these angles are 60 degrees, and if this angle and this angle is 60 degrees, that means this angle is 60 degrees, and also you can see the circle. So yes, we've just proved these are equilateral triangles. So I'm going to show you the method I used. What I did was I drew a line on my exam sheet, so you're allowed to do that, down the center. Okay, what is the length from here to there? What's the length from here to there? Since this is an equilateral triangle, and we cut this line in half, it's going to be 3.5. This length is 7. This length is 3.5. You can use algebra and Pythagoras to work out this length. So we know that 3.5 squared plus x squared is going to equal 7 squared. Now, this is not going to round off easy, so just bear with me. If I remember, 3.5 squared. Yeah, just a second, guys. 3.5 squared was equal to 12.25. 12.25 plus x squared equals 49. Then do 49 minus 12.5, you should get 36.75. So x squared equals 36.75. Okay, and since we can square root it, so you get the square root. The square root of 6.75. That is x. That is the height of one of these. And what you can do is you can see that there are 6 triangles. So basically you know the area is going to be 6 times the area of the triangles. And the area of each triangle is going to be height times base divided by 2. So since it's all divided by 2, we're going to just change that to 3. 6 divided by 2 is 3. And then you have, just to work out the 7 times the height, which is the square root of 36.75. So you'd get 3 times 7 times that. So you'd get 21 this. That would be your answer. 21, the square root, and that's the area. So type this into your calculator. 21 times the square root of 36.75. You're gonna get 127.3057,344. Cancels down to 127 square units, wasn't it? See, I think square centimeters. I'm gonna just say square centimeters. So you guys, you got it there. There is your. Oh, I forgot about doing the. Yeah, sorry guys. I nearly stopped us there. I totally forgot. I said I was gonna prove it 2 ways. So yeah, so you saw there the answer was 127. I'm gonna just. Now, because if you did a different way, due to rounding errors in calculators, you got a slightly different answer, but it should all give you the overall same answer. 127.305, 7344. That is the answer I got via Pythagoras. So I'll just say Pythagoras. And you know, I'm just going to delete all this and draw one in there. Pythagoras answer was 127.305 7344. Okay. Now, I know some people have come up to me, like Tom Saunders told me, they used Triggy to solve this question. I love Pythagoras. I don't like trigonometry because it doesn't have much squareness in it. Square rootness. Yeah, so let's start again. So we know that each length is 7. We can still have access, and we know that this length must be 60. Guys, I'm going along because I've never done this before. Now, what must this length be? It must be yeah, you're gonna actually get the exact same answer because of stuff. But yeah, let's do this anyway. You know that we're obviously going to be using well, you have the hypotenuse and the opposite, so it's going to be sine. Sine, not sin, sine. Must I put the E? Okay. Sine, opposite is x. Oh, yeah, sine theta, or sine 60 rather, is equal to x divided by 7. You can just multiply both sides by 7 to get 7 sine 60 is equal to the height. And you can then carry on and work out that 27 times, so instead of doing everything, we're just going to do this. You can cancel the 27 times 7. So it's 27 times 7, 189. 189 sine 60. So 189. Whoa. Whoa. What? That ain't the answer I was looking for, but give me a second, guys. Yeah, it is sine 60. You need, yeah, it's 21 still. 21. So this is the height. I'm just a bit confused because it didn't give the correct answer. 20. What if it's 21 sine? Maybe 7 sine 60 times 21. Yeah, it works, guys. It works as well. It's interesting. I did 7 times 21, guys. Oh, so yeah, I must have made a typo the first time. Must have done 28, right? Yeah, I must have done something else. But yeah, 7 times 21 gives us 147. So 147 sine 60 would be our answer. And when you type that into your calculator, you get 147 sine 60 equals... I'm gonna type this in for the tension's sake. Dun, 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 dun. 127.3 05 7 344. What? Exactly identical. Wow. That must mean, that tells you something about these calculators. They're not just rounding stuff off. And trust me, these things, these calculators do not, are not that accurate as far as that, which means this proves that sine calculations have something to do with the square root of numbers. Isn't that cool? Yeah, so guys, these are your answers. Well, yeah, these are your answers to these questions. Yeah, you should have got these, otherwise you're not that good at math, or you just couldn't be bothered. You know what, something really shocked me, guys? You guys know Jonathan Tam, right? He didn't do this question. I'm so ashamed. Yeah. So guys, these are your answers. You should have got them. If you didn't, you got something wrong going on. Yes, so there you go, guys. I just taught you guys how to solve these 3 of the toughest questions on the math paper. I hope you understood it. And guys, by the way, I'm going to be uploading a special video dedicated to my good friend Calian. And I'm not doing it just because he subscribed to me. No, I'm not taking a bribe in any way. Yeah, I'm not. Trust me, guys. I am doing this because he's my friend. I don't do stuff for people just because they do stuff good for me, and yeah. Okay, guys, I will see you then. Check out that number, guys. It's gonna be awesome. Okay, yo, guys, make sure you subscribe to Math Logic. You learn loads of math stuff, especially for your future tests, and you don't want to mess up your final GCSE. So I'd recommend coming over. I'll give you loads of tips. And yep, this is JK, Josh K, talking about our math exam in November 2013, innit? Yeah. See you guys.